Alright, hey guys, welcome to today's video. We're going to be going over how to work with and understand the periodic table. But first, you must complete this super cool, totally awesome chemistry word scramble. The word scramble is what will, I guess, air quote, unlock the rest of today's video. So go ahead, pause the video, try your best, and then hit play once you're done. Okay, here are our answers. 1 atom, 2 proton, 3 nucleus, 4 neutron, 5 electron, 6 periodic table, 7 elements, and 8 chemistry rocks. Alright, moving right along, we're now going to cover the parts of the atom. The nucleus is the center of the atom and is a majority of the atom's mass, meaning that is where a majority of the atom's weight is located. The proton, located within the nucleus, has a positive charge. The neutron, also located within the nucleus, has a neutral charge, meaning it's kind of just there. The electron orbits or circles the nucleus and has a negative charge. Now, why is it important for us to know all of this information about atoms when working with the periodic table? Elements on the periodic table are arranged based on their atomic number. The atomic number is the number of protons in that element's nucleus. Now down here we have a wonderful example of how elements appear on the periodic table. Here we have carbon, which, as you can see by the lovely bold arrows, that is the element name. The atomic number, which is the number of protons in carbon's nucleus, is 6. Carbon has 6 protons. The element symbol C, atomic mass. Now the atomic mass is equivalent to the number of protons and neutrons in that atom's nucleus. So carbon has an atomic mass of 12.011. Now that we know the basics of the atom and how to read elements on the periodic table, now we can actually look at the periodic table. Now the periodic table is grouped and bundled in numerous ways, and we're actually going to look at those now. And the first way is with periods and groups/families. Periods run horizontal, obviously, as you can tell by this wonderful bold neon green box and arrow, and groups and families run vertically. So let's see, here in this green box we've got sodium and magnesium, and even though there's this space of nothingness, we continue over in the same column and we come across aluminum, silicon, phosphorus, sulfur, continuing on, and because those are all horizontally in the same line, those are all in the same period. And over here in our wonderful blue box, we have helium, neon, argon, krypton, and you just continue down vertically. And if those elements are all lined perfectly underneath each other, then they are all in the same group or family. Now let's take a closer look, because it always has to get more complicated, because that's just how it is. Now periods. All of the rows read left to right, as we just did. When you look at the periodic table, each horizontal row is called a period. Just went over that. All of the elements in a period have the same number of atomic orbitals, or electron shells. And those are basically the numbers of rings an atom has. And those rings are what the electrons orbit or circle around to stay on the outside of the atom or the nucleus. Every element in the top row or the first period has one orbital for its electrons. All of the elements in the second row or the second period have 2 orbitals for the electrons. And you keep going, you keep going. Third row, 3 orbitals, fourth, 4. and as we move down the table, every row adds one orbital. Therefore, there is a maximum of 7 electron orbitals. And as you can see here with this lovely diagram of lithium, it has 2 orbitals, or 2 rings. Therefore, we know that lithium is in the second period on the periodic table. Now looking at groups, or families. Each vertical column is called a group. The elements in each group have the same number of electrons in the outer shell. Now with periods, we're looking at atomic orbitals or electron shells, the things the electrons follow, basically. Groups, we're actually counting how many electrons there are, but only in the outermost ring, shell, orbital. Those outer electrons are also called valence electrons. Valence electrons are involved in chemical bonds when that element bonds with another. Every element in the first column, group 1, has 1 electron in its outermost shell. Every element in the second column, group 2, has 2 electrons in the outermost shell. And you just keep going, just as we did with periods. And as we can see here with our wonderful diagram of sodium, in the outermost shell, there's only 1 electron. So we know that it must be in the first column, or group 1. And looking further, we can see that it has 3 atomic orbitals, or electron shells. So we also know that it's in the third row, or third period on the periodic table. Alright, moving right along, we're going to look at another way of bundling. As you see here, the periodic table has 4 blocks: the S block, P block, D block, and F block. Now, we're not going to go into these in extreme detail, because these are mostly used with electron configuration, which we won't be going over today. But be sure to note which columns, which rows are included in what blocks. And be sure to notice helium over to the far right. He is in the S block. Yes, he is all the way over there in no man's land, but he is included in the S block. Moving on to yet another way of bundling. As you can see, the colors below indicate groups. Looking at the column farthest to the left, vertically listed under the Roman numeral 1, excluding hydrogen, those elements are alkali metals. And looking at the elements farthest to the right, vertically listed under the Roman numeral 8, those are noble gases. Go ahead, pause your video, take note of the different kinds of groups, and if you have a periodic table handy, go ahead and note what groups are located where. Now there actually is a simpler way to do things. Instead of dealing with all those different colors and groups, we've broken it down to simply 3: metals, nonmetals, and metalloids. And now we're going to look at these 3 in more detail. Alright, looking at metals. The following are characteristics of metals. They are shiny, solid at room temperature; malleable, meaning they can be hammered flat; ductile, meaning they can be pulled through a wire; and they are highly conductive, meaning they can produce and transfer electricity. Moving right along and looking at metalloids. They are solid at room temperature, brittle, meaning they're hard, and they are also semiconductors, meaning their conductivity value falls between that of a conductor, such as copper, and an insulator, such as glass. And finally, looking at nonmetals. They are not shiny, they are insufficient conductors, meaning they are not good when it comes to producing electricity. They are usually a gas at room temperature, and when they are in their solid form, they are brittle, or hard. And now, to wrap things up, we have a quick review. For the following questions, please pause the video, try your best to answer all of them, and then hit play once you're done. So, first question. Define the following parts of the atom. Alright, welcome back. Starting at the upper left corner, you should have said neutron, proton, electron, and nucleus. Alright, same as the previous question. Pause the video when you're ready to answer, and hit play when you're ready to see the correct answer. Now, look at the bottom. Fill in the 2 blanks below. Alright, the 2 blanks were, starting on the top row, red indicates alkali metals, and brown indicates metalloids. Alright, and by now, you know the drill. Lastly, the qualities define what? Shiny, ductile, and conductive. Do these describe metals, nonmetals, or metalloids? And if you said metals, you were correct. And that concludes today's chemistry video. I hope you gained something today. I hope you took lots of notes. And I hope now you feel a little more comfortable with the periodic table. Thanks for watching, and have a great day.